let's use these two shapes and put them next to each other so that one side of the equal sides in the second triangle is adjacent to one of the sides of the first triangle. So now, this is what I will have. It will be like a rhombus. Now in question 6, we will write, what can we create a parallelogram or a rhombus? What did you think? Now we also said it can be a square or a rectangle. I've already answered this question. Exactly. Why? Because we do not have any right angles over here. So this means that this shape can be a what? Parallelogram or a what? Or a rhombus. Now in question 7, what do I see? This is an easy question. We have to select two sets of triangles that can be joined along one edge to create a quadrilateral with right angles. So which one is the answer? It is clear that the triangles A and C do not have any right angles. So therefore the correct choice is B and D. Now I want you to pay attention, as the area of the quadrilateral that we have created after joining both triangles is double the area of one triangle. Now do you remember the meaning of an area? The simple concept of the area means that the area for any shape is the number of equal parts into which the shape is divided. Now let's apply the definition and draw some shapes with different areas. This is what we will do in the next activity. Let's check the next activity. So this is the next activity over here. It's called whole number tiling. Now in problem 1, we are asked to count the unit tiles to determine the area of the rectangle. I will give you time to count until the unit tiles, and we will continue our discussion when we get back. Now that we're back, I'm sure you were able to answer the question correctly and found that the number of tiles is 35, which means that the area of this shape is 35 square units. Let's write it together. So the area is 35 square units. Now maybe one of you counted all the tiles, but this way would take too much time. Also, you could count the tiles incorrectly, especially if the shape is greater than this one. Now, my students got it correctly in a correct way. So, could you do the same way? My students counted the units of the length, which were what? 7 over here. And then they counted the units of the width, which were 5, like that. Then they multiplied both dimensions. So the 7 times the 5 is going to be the product of what? 35 units squared, which is the same answer that we've already got. Now they use the area formula for rectangles, which we have learned before. And it is the multiplication of the length times the width. So the area is the length times the width for the rectangle. And we will apply this formula today when we have whole numbers as well as fractions as dimensions for rectangles. Now let's check problem 2. In problem 2, we're asked to draw a rectangle with a length of 15 units and a width of 12 units. You can draw easily on the grid. This is going to be left for you. Do it after the session. Now let's go and check problem 3. What do we have? We're asked to find the area of the rectangle that we drew in problem 2. As we have mentioned, what was the area of the rectangle? Let's write it one more time. The area was equal to the length times the width. So what are we going to get? The length was 15 and the width was 12. Now, you can use any strategy that we have taken before to calculate the product. At the end, you have to get the same answer, which is 180 unit squared, like that. Now, let's move on to problem 4. Let's take a closer look over here to problem 4. We're asked to find the area of the rectangle below by tiling, just to reinforce the concept of the area. Now, after we finish our lesson, you can draw the same dimensions you have here on a graph paper, or use the shape and divide it into tiles. Now, let's move on to problem 5. We're asked to draw a rectangle with an area of 24 units squared. So, let's use the board for this activity, and we will draw it together. Let me head over there to the board. So let's check before we draw. First, we have to think of the dimensions that we have of the rectangle. Now, the area that we need is 24 square units. Now, we know that the area is equal to the length times the width. So, we need to think of a factor of the factors of 24. Now, we have many factors to pick from. For example, if I'm talking about 24, this can be what times what? This can be 1 times 24, right? It can also be what? 3 times 8. So, it can be 3 times 8. What else? It can be 4 times 6, right? So, one of these factors could be used as the dimensions of our rectangle. So, I'm going to choose the 4 and the 6. So, this is what I will choose, the 4 and the 6. Now, let's draw the rectangle. So, for the rectangle that we have here, I will take the 6 as my length. So, let's say I will start with this point over here like that. I need to count 6 units. So, 1, 2, 3, 4, 5, 6. So, this is the end over here. With that, I have my dimension. Let's draw it like that. This is my length. Like that. Now, what about my width? The width is 4. So, I need to count 4 units. So, let's count. 1, 2, 3, 4. Like that. So, these are the dimensions that I have. Let's connect our rectangle like that. So this is my rectangle. Now, all the previous problems, the dimensions that we have were what? Were drawn like that as whole numbers. And we found them easily counting the units into which the shape is divided. Or we multiplied the length by the width. Now, what if the dimensions that we have are fractions? How would we get the area? And this is what we're going to learn in the next activity of Build, titled Tiling with Fractional Dimensions. Now, in this activity, we have here attached a graph paper and the rectangle is drawn. I will give you time to find the area of the shape with any strategy that you prefer. Then I will share with you the strategies that my students use when we get back. Let's start. Now that we're back, were you aware of the halves while you were finding the area? Let's see how my friends or my students calculated the area. Now, one of my students said that he counted the whole number tiles. So when I check over here, there were 6 whole, while we have 3 halves over there like that. So the area is going to be what? Let's check. If I have here the 6 wholes plus the 3 halves, which is 1.5, right? The total area is going to be what? 7.5 square units. 7.5, like that. Another one said that he counted the tiles in one column, and they were what? Let's check. 2 and a half, like that. And there are 3 columns. So now he multiplied the 2 and a half by 3. So the second method was to multiply the 2 and a half by 3, like that. And again, you are going to use any method. You can also use the what? Distributive property, which means we're going to multiply 2 times 3 plus half times 3, which is also going to get what? 7 and half. With that, we will also get the area as 7 and half by any strategy that we're going to use.
تقدر تتابع كل دروسك على تطبيق مدرستنا بلس. مدرستنا، المستقبل يبدأ الآن.